What is Delta Lake? In order to answer this, we are going to go through quickly over the Delta Lake paper. The Delta Lake paper is called Delta Lake High Performance ACID Table Storage over Cloud Object Stores. Okay, so from this, you can already see what's the purpose of Delta Lake. They mention in the title ACID, atomic consistency, isolation, durability for databases, high performance, table storage over cloud object stores. The case is this: we have all these relational databases and data warehouses, data marts that are relationals and support ACID transactions. But when we want high superscale on the storage of the database, then we moved away to cloud object stores or just local object stores. Think of it as S3. This is the data lake. Data lake is the place where we throw everything. But we lost on the way the ACID transactions and all the things that come with it, such as benefits such as updates. But benefits such as updates are only a result of the ACID transactions that we get. So Delta Lake bridges the gap, and it would do a trick in order to gain back on object data stores on the data lake, to gain back the ACID qualities of databases, the ability also to do time travel. This is a result. All of this is a result of adding a journal log, the documents which changes we do on the data lake, and then we get ACID. Once we get ACID, we can do additional operations such as updates, upserts, fast metadata fetching, we'll talk about it, and time travel. How do they achieve the ACID transactions, the time travel, and fast metadata? And I want to stress out again, the main purpose is the ACID, okay, atomic consistency, isolation, durability that we had in relational databases. All the rest is a result, a side effect of the fact that we have added a mechanism to support ACID, the time travel, the fast metadata, and the ability to do updates, upserts. Okay, so how did they implement it? The core idea is this. First, they try not to add yet another service, because we could say, and this is I think what Snowflake is saying, anytime you want to get to the data lake, you need to go to this service, and this service could say, okay, you are trying to get the same object. No, another one is writing now into it, so I won't let you. So if we went to another service into the data lake, we could achieve this ACID, but then we would lose. We are adding additional complexity, we're adding another service, everything needs to go to this service. So their approach was good, and it's basically, I think, the same approach that Iceberg and another project are taking, which are solving the same problem. They added another folder in this. So in your object store, you would see another folder for wherever you write your files, which is called Delta Log. And this Delta Log, anytime you do a change, it will store the change in files. So they added metadata files. And when we go with Spark into the Delta Lake, we use the format Delta, which is currently probably using the format Parquet under the hoods for the actual data. And this Spark library will interact with these journal log files, such that if there is an optimistic locking problem, if the data we are trying to get is not the latest one, it would know to return us the latest data, because the journal will track the revisions of the files, which is the latest. Basically, with the journal, we could say, in order to get this folder, the journal would tell us, here are the list of files that you need to get, and we would get them, and even if there was an update, then the journal would add, and then they could add additional components of top of it, such as compaction from small file to large file, and caching, and data layout optimization and schema evolution, because the schema now can be written in the metadata, which is attached to the file, and audit logging, who is doing the change, all this in the metadata. So basically what it did, we added a layer on top of data lake, on top of the object store. In most cases, it does not have a service. There is a specific use case in S3 where they currently need a service in order to support the ACID, but in most cases, it does not have any service. And then with this log, they log whatever operation we do, and they have checkpoints. You can do time travel, upserts, delete, merge operation, efficient streaming. How can we do efficient list of the objects? Just go to the journal files. No need to actually scan all the files. Because if we do scan all the files, then most cloud providers will limit for 1000 results and so forth. But here in the journal, we can read a single file and get all the files that are there. So this is some kind of an evolution from data lake to data lake. So it's data lake plus plus. Data lake plus that contains additional features, especially ACID features.